Let us look at proposition number 18 of book 6 of Euclid's Elements. The proposition says to describe a rectilinear figure similar and similarly situated to a given rectilinear figure on a given straight line. So we are given a straight line, we are given a rectilinear figure, we have to construct another figure which is similar and similarly situated to the given rectilinear figure. Okay, so let's begin. So first thing we'll do is we'll join D and F. Then we will copy angle C at A. Let's see, since we know how to do the copying part, I'll just mark the point at which this will be forming that angle. So angle BAG would be equal to angle DCF. Then we copy angle FDC at B on AB. When we do that, we get this polygon, which is hopefully is similar to this polygon. Now you can guess what the next step would be. Now we copy angle DFE at G on GB. Okay, again, I'll just mark the point, and this would be the polygon. So we copied this angle and we copied this angle. This angle is angle EDF at B on BG. Now we have to prove what? We have to prove that this rectilinear figure and this rectilinear figure are both equiangular, and the sides of this polygon is in proportion to the sides of this polygon. Okay, let's begin. Angle DCF is equal to angle BAG because we copied this angle here. Angle FDC is equal to angle GBA because again we copied this. Now in triangle CFD and GAB, two angles are equal to two angles. That means the third angle is also equal. We know DFE angle is equal to BGH because we copied this angle here, and we know angle EDF is equal to HBG. Why? Because again we copied this angle. So again in these two triangles, triangle FED and GHB, two angles are equal to two angles. That means the third angle is also equal. Yes. Now, remember, we are not talking of individual triangles. We are interested in the overall figure. So here, if you look at angle CFE, that is the sum of these two angles. Angle AGH is the sum of these two angles. So since these two angles are equal to these two angles, that means their sum is also going to be equal. So that means angle CFE is equal to angle AGH. Similarly, angle CDF is equal to ABG. Angle EDF is equal to HBG. So since these two angles are equal to these two angles, their sums will also be equal. That means we have shown that angle C is equal to angle A, angle D is equal to angle B, angle E is equal to angle H, and angle F is equal to angle G. That means these two figures are equiangular. Now, in these two triangles, triangle FCD and GAB, since they are equiangular, sides about the equal angles will be in proportion. That means we can say FD is to GB as FC is to GA, which is in turn is to CD is to AB. Similarly, FD is to GB as FE is to GH as DE is to BH. But here if you notice, FD is to GB is equal to these two ratios, and these two ratios. That means we can combine these two statements into a single statement and say FD is to GB equal to FC is to AG equal to CD is to AB equal to FE is to GH equal to DE is to BH. So that means all the sides of this polygon are proportional to the corresponding sides of this polygon. And we have already seen that these angles are equal. Corresponding angles of these polygons are equal. So that means this polygon ABHG is similar to CDEF, which is what was the required proof for this particular proposition. So that is proposition number 18 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.